We are given a question on identities. Now in this question we are asked to find if cos theta is root 3 over 2, evaluate cos theta minus cosec theta all over sec theta plus tan theta. Now we are given that our cos theta to be the root of 3 over 2. And we are asked to find the value of cos theta minus cosec theta all over log sec theta plus tan theta. So how do you solve this? Before we solve this, we have to know the value of each of the identity. So in this case, we have that our cos theta here is root 3 over 2. So remember that our cos theta is gotten from CAH. So cos theta, which is A over H. So it means that where I have my A should be root 3 and where I have my H should be what? 2. That's the meaning of cos theta. So if I have my A to be root 3 and I have my H to be 2, I can easily get the other derivative by making use of a triangle. Now using a triangle, a right angle triangle to be specific. In the right angle triangle, we have our perpendicular angle and we have the angle theta. In this case, is our adjacent, and we are given that our adjacent is root 3 and we have our hypotenuse to be 2. But we don't know our opposite. And for us to get our opposite, let's assume our opposite is x. We are going to make use of Pythagoras theorem. Now using Pythagoras theorem, we are going to have that our hypotenuse squared equals to opposite square plus the adjacent square. Now where's our hypotenuse? The value of our hypotenuse is 2. That's 2 squared equals to your opposite. Let's assume is x. That's x squared. Then your adjacent is root 3 all squared. Now 2 squared is given to be 4. Then here is x squared. Then in this case, root 3 can cancel out 2. So I'll be left with 3. Going on with this, I can get the value of my x. I will say x squared equals to 4 minus 3. Then I have that my x squared equals to 4 minus 3 will give you 1. Looking for the square root of the both sides. Cancel out the square. So I left with that x is 1. So that means my opposite is also 1. That's the value of our opposite. Now that we know the value of our opposite to be 1, it now be easy for us to get other derivatives. Now let's look for a way we can get other derivatives. First thing first is that we know the value of our cos theta to be cos theta is given to be the root 3 over 2, while sin theta, which is so, is given to be 1 over 2. Then our tan theta, which is TOA, that means COA. So opposite comes first, that's 1 over root 3. Sorry about that. Now moving on with it, you can also get the inverse of each of them. The inverse of cos theta is known as what? Cosec theta. So now I'm going to have it as 1 over, sorry, that's actually wrong. The inverse of cos theta is known as sec theta. And that can be written as 1 over cos theta. And you know that our value of cos theta is root 3 over 2. When I find the inverse, it means my root 3 will come to the bottom and my 2 will move to the top. So I'm going to have it as 2 root 3. That means 2 over root 3. Done with that, then the inverse of our sin theta. The inverse of sin theta is known as cosec theta. And cosec theta is 1 over sine theta. Now, if you notice that the value of our sine theta is 1 over 2, so when I look for the inverse of 1 over 2, it means the 2 will go up while the 1 will come to the denominator. I'm going to average it as 2 over 1, and 2 over 1 is also known as 2. So the next one is our tan theta. The inverse of tan theta is what? Cos theta. That means 1 over tan theta. So for me to get the value of cos theta, the value of our tan theta is known as 1 over root 3. So when I find the inverse, it means the 1 will come to the bottom and the 3 move to the top. So I'm going to have it as root 3 all over 1. And root 3 all over 1 is also known as what? Root 3. So now that we know this, the next to do, we have to find the value of cos theta minus cosec theta all over sec theta plus tan theta. Now let's look at it. What's the value of our cos theta? A quick one. Again, let me write it to have a perfect answer. We have that our cos theta minus cosec theta all over sec theta plus tan theta. Our cos theta is given to be root 3, so I have it as root 3, minus my cosec theta is given to be 2, so I have it as 2, all over our sec theta is given to be 2 root 3, so I have it as 2 all over root 3, plus my tan theta from here, tan theta is given to be 1 over root 3. So I'm going to have it as 1 over root 3. So the next thing to do is to consider your denominator. We can find the LCM in the denominator by saying root 3 minus 2 all over. The LCM in the denominator is root 3. So that means I'm going to have the numerator with 2 plus 1. Going on with this, so we have root 3 minus 2 all over 2 plus 1 is given to be 3 all over root 3. Now if you look at it carefully, it can also be written as root 3 minus 2 divided by. So we are going to have that 3 all over root 3. And we can actually assume this to be over 1. This is our division sign. Sorry. The division sign here can turn to multiplication, and when it turns to multiplication, we are going to have it as root 3 minus 2 all over 1 multiply the next fraction we go upside down, in which we are going to have root 3 all over 3. So I'm going to have, when I try to multiply this with the numerator here, I'm going to have root 3 in bracket of root 3 minus 2 all over. When we multiply 1 by 3, we're going to have answer to be 3. So in the long run, we can try to open a bracket by saying root 3 multiplied by 3. I'm going to have ordinary 3, because anytime you are multiplying sort of the same base, you are still going to end up having the base as a. So that's why we're having there as 3. And going on, the same root 3 multiplied by 2 will give you what? Minus. We give you minus 2 root 3 all over 3. So this is what we have to solve. Hence, we have the answer to be 3 minus 2 root 3. Let's consider our option whether we have such an answer. So consider the option, the right answer is our option A, which is 3 minus 2 root 3 over 3.